Welcome. Today we're going to talk about the gradients of perpendicular lines. Gradient is the British term for slope. Slope is the American word for gradient. We're going to look at what we can say about the gradients of perpendicular lines. Let's refresh our memories. These two lines are parallel. You can tell by the two arrows. That means these lines are parallel. Parallel lines never meet, however long you make them. And also they have the same slope. They have the same steepness, the same gradient. These two lines are perpendicular. Perpendicular lines meet at a 90-degree angle. This angle is a 90-degree angle. Something else we'll be using that we assume you still know. Slope and gradient mean the same thing, and they describe the steepness of a line. They're calculated by dividing the rise of the line by the run of the line. An example, if this is a line and it's a straight line, we pick two random points on the line and we calculate what the rise is. Say this is a rise of 1 and this is a run of 2. The rise is up, so it's positive. The run is towards the right, so it's positive. If the rise goes down, it would be negative. If the run went to the left, it would be negative. Yeah, here we have a positive slope. Here the slope would be rise of 1 over run of 2, right? Another thing we want to remind ourselves of is what the word reciprocal means. The reciprocal of a number x is equal to 1 over that number. So if we had the number 2, its reciprocal would be 1 over 2. If we had the number 0.5, its reciprocal would be 1 over 0.5, which is 2. Ooh, if we had a fraction, 2/3, its reciprocal would be 1 over 2/3, which is the same as 3/2, right? The reciprocal of 2/3 is 3/2. A nice, helpful property of a number and its reciprocal is that when you multiply them, they always give 1. X times 1 over x is 1. 2 times a half is 1. A half times 2 is 1. 2/3 times 3/2 is 1. So a number and its reciprocal always multiply to give 1. Today we're going to use the term negative reciprocal. All that means is that we put a negative sign in front of the reciprocal. So the negative reciprocal of x would be 1 over x, its reciprocal, with a negative in front. Yeah? That's negative reciprocal, and that's what we're using today. Yes, I promised I would tell you something about the gradients of perpendicular lines. Here I've drawn two perpendicular lines. AB is the red line, BC is the brown line. They meet at a right angle, so they're perpendicular. If I look at the steepness of this line, look, I can go up and to the right. I go up 2. I go over 3. Interesting. These lines are perpendicular. Look what happens when I turn my piece of paper 90 degrees. Look, 90 degrees. And I now look at my brown line. Do you notice how it has the same rise and run if I turn the paper? All right. This is a way you can always draw perpendicular lines without using an angle measuring device. You always know that if I turn my paper 90 degrees, then it has the same steepness, right? Thing is though, when we are looking at lines, we usually have axes. The axes tell us what is up and what is down, how we should hold our paper, right? This is now the origin. And this is the horizontal line. We have to hold our paper like this, right? We can't say, okay, we're turning it. We can still turn it, but this is the way we're supposed to hold our paper. And this tells us what is positive and what is negative, what is up and what is down. The slope of AB is 2 over 3. Let me write that down. Slope, I should say gradient. I choose to say gradient of AB is 2 over 3, right? Rise over run. The gradient of my perpendicular line, called BC, is up 3, back 2. 3, negative 2. 3, negative 2. So what have we learned? And this is true for all perpendicular lines. The gradients of perpendicular lines are negative reciprocals of each other. Negative reciprocals, that is the term that I just showed you. Negative reciprocals of each other. What I forgot to tell you is that when you multiply reciprocals with each other, you get 1. Of course, when we multiply a number by its negative reciprocal, we're going to always get negative 1, right? X times negative 1 over x gives us negative 1, and that's true for all numbers and their negative reciprocal. They multiply to give 1. It's a way to check whether you've gotten the negative reciprocal correct. Gradients of perpendicular lines are negative reciprocals of each other. That means that 2/3 must be the negative reciprocal of 3 over negative 2, and also the other way around. Let's see if that's true. Let's multiply these two together to see if they give negative 1. 2/3 times, I can put the negative in front, right? Times negative 3/2 equals negative 6 over 6, which equals negative 1. So this is a pattern, a rule that we can use in all sorts of fun problems. Let me show you one very interesting one. We're being asked to find the equation of the perpendicular bisector of the line joining point A to point B. what we want to do here is we need to have a system. If we find the gradient of line AB, we can then find the gradient of the perpendicular bisector. Right? Let's look at what a bisector is. A bisector cuts another line exactly in half. So the line AB is going to be cut exactly in half. So the point where that happens is the midpoint between these 2 points, right? So we need to find the midpoint of AB. So that means we'll have a point where the perpendicular bisector passes through, and we have the gradient of the perpendicular bisector. That information is enough for us to find the equation of the perpendicular bisector. Let's first do the steps that I just showed here. The gradient of AB, remember how we find the gradient, how we calculate the gradient is the difference between the y values divided by the difference between the x values. y2 is 2. Y of the first point is 4, so minus 4. The x value of the second point is 2. We're subtracting the x value of the first point, that's negative 1. 2 minus 4 is negative 2. 2 minus a negative 1 is equal to 3. So the gradient of AB is negative 2/3. The perpendicular bisector is, the gradient of the perpendicular bisector is the negative reciprocal of this. So negative times the negative is a positive, 3/2. That should be the gradient of the perpendicular bisector. Let's quickly check whether this is true. Let's multiply them together. Negative 2/3 times 3/2. Does that equal negative 1? Let's see. Negative 2 times 3 is negative 6. Divided by 6, and that is negative 1. So yes, that is the gradient of our perpendicular bisector. Now let's find the midpoint between these 2 points. Remember how we find midpoints? We add up. It's like we take the average of the x values, right? And we take the average of the y values. The average of the x values is the 2 added up together and divided by 2. Same for the y values. You add them up, divide them by 2. In this case, that would be x1 plus x2. That equals 1, right? 1 divided by 2. The y values added up, 4 and 2 is 6. We divide that by 2. Okay, so our simplified coordinates would be 1/2. 6 divided by 2 is 3. So the midpoint of AB is 1/2, comma, 3. And that seems reasonable because between negative 1 and 2, exactly between those two is the point 1/2, right? And exactly between 4 and 2 is 3. So this is the midpoint between A and B, and we know that the perpendicular bisector say this is our line. We've now found the midpoint, 1/2, 3, and we know that our perpendicular bisector passes through that point. It's the point that these two lines share, right? We also know the slope of our perpendicular bisector, we saw that it was 3 divided by 2. So we're almost ready to write the equation of this line. Remember, this is the form that we often see for a straight line. Y is equal to mx plus, did I say b? In our book, we use c. M is the gradient. C is the y-intercept. We know the gradient. We don't know the y-intercept. Let's put the gradient in there because we want to write out the information that we have. The slope here is 3 over 2 x plus c. Okay, c is still unknown. What we do have, though, is one coordinate that this line passes through. We have an x value of 1/2 and a y value of 3. If we plug this point into this equation, it should be true. If we plug this point in here, our only unknown will be c. So that's super helpful. Let's stick it in. Y is 3. 3/2 times 1/2 plus c. So 3 equals 3.5 times 3/2, times 1/2 is 3/4. Yeah. 3/4 plus c. Solve for c. C equals 3 minus 3/4, so 2 1/4. That is the y-intercept. We can replace this c by 2 1/4. And that actually gives us the entire equation of the line. See how this was the equation of the line? Y equals the slope, or gradient, times x plus y-intercept of 2 1/4. This would be our answer. Nice. It's a fun little puzzle. We use everything we learned. We're finding midpoints. We're calculating slope. We're taking the negative reciprocal of a slope to find the slope of the perpendicular bisector. We're using the point that we know is on our line to plug it in to the equation of the line to find the c value. And as soon as we have c and our gradient, we have the equation of the line. That is so much fun. All right, see you guys later.